Hello, this is Paul from Foresight Tech. Today we start Calc 2 by considering two classic problems in the history of mathematics. The first is how do you find the area under the curve. The second is how to estimate the distance. In the lecture today, we focus on the first problem. The objective is to estimate the area under curve. So I showed you three figures here. I will show you the idea. Okay, so the problems if we have a curve, so like a function, so two-dimensional functions here, and the curve under the area under the curve, which means so this small area. Okay, how to find the area, because the shape is not regular, so we don't have a formula for us to do. This is very ancient problem. Should be went back to about 2,500 years ago in ancient Greek, Archimedes. The original idea should be go back to Archimedes, and the exact formula should start from Isaac Newton. Okay, about 350 years ago from Isaac Newton. After Isaac Newton proposed the limit idea, so we can formulate all these problems in a system by using limit definition. Okay, so let's look at the first graph. We have an area, so which is the area under curve, and we can approximate the area by do this. Okay, divided AB, this interval, by evenly by 2. I mean, cut one time. So we have one part, two part, and then we can draw a rectangle. See, we can draw another rectangle. Of course, the height of the rectangle we use the right endpoints. Use the function value at the right endpoints. I mean, these two. The sum of the rectangle, we're going to approximate the area under the curve is what I wrote here. The area under the curve can be approximated by the sum of the rectangular area. However, the rectangle with the height is at the right endpoint, like f at b. F at b, this is how high of the second rectangle, right? Okay, so this value is how high is the first rectangle, and later I will introduce what is the left endpoint. Okay, so this we use the right endpoint, so that's why we use R, and the 2 means two rectangle, okay? Evenly divided. So we look at where the area. Okay, the area is there. So this is overestimate, and this estimate is overestimated because we have more area you calculated. So we look at it, the area is very big, right? How to reduce the area? Okay, so we can do this, divide it more times. So in this graph, I divided the 4, evenly divided by 4. Okay, so we have 4 rectangles, and this time we still use the right endpoint value as the height of the rectangle. So look at it this time. What is the area? What is the area? If we do approximation, the area is this part plus this part plus this part plus this part, compared to the left graph. Okay, so this area is much smaller than this, right? And we look at one more time. If we divide it more time, if I divide it by 8, okay, we use 8 rectangles, the areas, to estimate the area under the curve. This time a lot. Okay, so how many? 1, 2, 3, 4, 5, 6, 7, 8 evenly divided. So the height of each rectangle is at the right end point. So we look at it, the area is this small. Okay, so this is smaller than this one, and of course it's smaller than the first one. And we look at it, we can see a pattern this time, right? The pattern is divided by more times, we will get less area. If I write here, we will get a very important results. The result is this. If I simplify, use more divide less error, right? Okay, so we will find these results. Okay, this is the results. If you divide it by more times, you get a less area to estimate the area under the curve. Of course, and the Isaac Newton proposed a limit definition. So we discussed the limit definition in Calc 1. And if the limit exists of this sum, okay, R2, R3, R4, R8, R10, R100, R1000, if the limit exists, we can define the area under the curve by the limit. That's exactly proposed from Isaac Newton 350 years ago. Okay, this is very important. But how to find the approximation? In general, so everyone, so you get this. In general, we do this. Okay, and this time we look at the bottom. Okay, here already should the idea. More divided, less area. What we need, the limit is this R, and later we define this is a Riemann sum. Okay, it's a very, very important mathematician proposed the Riemann sum, and we'll show that later. So we need a general formula for what is the Riemann sum. Okay, it's RA, R4, and if we generally divide it by n evenly, so means what? The graph will choose like this. So this time A, okay, is the beginning, B is the end point. Okay, the graph is f, y equals fx is there. The area is under the curve. So how do you divide it? So we set up x0, and this is how to formulate. Everyone, A is we set up x0. So B we set up xn, and we have x1, x2, x3, x4, and the xi minus 1, xi that goes to xn minus 1, xn. This is all the points, and then we can find the parts. How many parts? We have n parts. x1 from A to x1, the first, the second, the third goes to n parts. And so here we say we will use the right endpoint. Okay, we will use the right endpoint as the height of a rectangle. So now we need to draw a graph. So like this is the first step. So we use the right endpoint as the height. So how to draw the rectangle for the first? I have to draw this. Get a little bit. So everyone, so can you see? Highlight. Okay, I use the value of the function at the right endpoint as the height of the small rectangle. Okay, this is the first. Okay, and the same. I will going to. This is the second, right? I will going to continue. This is the third. I ignore the middle one. This so. x1 corresponding to the first rectangle, x to the second rectangle, the third rectangle. So this the middle is the ith rectangle. And ignore others. Go to the last rectangle. Keep in mind with the right endpoint. Okay, so get a little bit higher. Okay, so this is all the rectangles, and we add the area of all the rectangle together. It's called the Riemann sum, right? So I put the height here. So how high is the first? Is f at x1 is not f at x0, the right point. The same. So what is the second height? Is f at x2. The right point, okay, the right point. So the third one going to this f at x3. The ith one should be f at xi, not f at xi minus 1 goes to the last. Should be the height is x at n. x at n is b, right? So this is the height. If I simply say, I put the words, the height is right endpoint, right? Is right, okay, right endpoint. So we have a questions, and we already draw the graph. So what is this? What is the formula, okay, for this is Rn, this is approximation, the right. So we have a name. So the sum of these the area, the sum of the area of this small right triangle, rectangle, so we call the Rn, okay. How to find the formula? So I will show the formula here, how to find. So we already divided, right? But we don't know what is. We know x0. Do we know x1? Do we know x2? Okay, we don't know. If we know x1, x2, so we know the height. We know the height times the width. The height times the width is the area. So all we need to do is find out what is x. That means the division. Okay, so we knew. So how do? So the first. So we need this delta x because it's evenly divided, and this is the increment. Okay, we say this. This is the increment, or the definition is xi minus xi minus 1. Means the distance from x0 to x1, or the distance from x1 to x2, all the same, right? So how to find this? This is easy. The first. The total distance is b minus a, so we use b minus a divided by how many rectangle, how many widths? N. So divided by n. We know b, we know a, we know n, so we know that x. So did the first, and then I will going to x0 we have, right? So I wrote it here. X0 we know is a. X1. What is x1? X1 is a, or x0 plus delta x, right? So it's x0 plus delta x. We know x0, we know delta x, so we know x1. The same as x2 is x0 plus 1 delta, 2 delta x. So plus 2 times delta x. Okay, I ignore. Okay, so we're going to what is xi? Xi should be this. This is I, right? So x0 plus I times delta x. We're going to the last xn. Xn of course is x0 plus n times delta x. If you do the calculation, plug delta x into this formula. So x0 is a, and the do calculation is exactly got to b. And we put this together. This is very important. We call it so all the x. If we have x, and then we can calculate what is r. So r is like this. I put the formula Rn, do calculation. Rn is all the sums of the area of the small rectangle. The first rectangle is f x1, right, times delta x. The second is this is the height, this is the width, so that's the area. The second is x2 times delta x. The third I ignore. The middle I continue to the last, which is the last area is there. X at the end, the right end point, okay, plus x. That one, so this is how to do calculation. But we can simplify a little bit. So this is a common factor. We can do this. We can factor out delta x, right? Okay, to simplify a little. And so what we get is this: fx1 plus fx2 plus plus fxn times delta x. Okay, so did the formula. So we already have. So I highlight the first formula we get. Okay, we have a name. This is R. We call the right endpoint estimation, or we call approximation. The bigger the end, the smaller the area, the better the approximation. Okay, and so this is the first. Don't forget it. So the first height is f at x1 is not at f at x0. The last is f at xn, the right endpoint. Okay, so we have the first formula, and then I will go to the second. So you can use the height. You can use the right endpoint as the height of the rectangle. You also can use the left. You also can use other point like the middle, like other points are we going to. So this time. So here, can you see? And now, so if you have the idea, so now it's much easier. I already draw the graph. So look at this graph. So I give a title is the left endpoint approximation. I need to draw the approximation. Where is the rectangle? Rectangle is the most important. And this is the divisions of AB, right? x0, x1, x2, x3 goes to xn. The first one, this time I will not use the right endpoint. It says the left, right? So we use the left. How high is the first rectangle is this. Okay, and then we highlight. See, what is the height? So if I put it here, and then what is the height? The height is the left endpoint. Okay, so is f at x0 this time. The same, the second is going to this. This is how high. The second rectangle is at here. The height is f at the left endpoint. We have x1, x2. We use x1, which means the left endpoint. See, this is different from the first. The third small rectangle I put here. And then, so this should be f at x2. Okay, I ignore the other one because to the ith. The ith this time is this two. Right? Okay, the height up here is f. This time is the left endpoint. I minus 1, not f at xi. Goes to the last. The last is this two. Okay. So how tall? The height is this f at xn minus 1. So we have all, and then we're going to formulate what is ln. Okay, what is ln? So the same, you know all the x, right? So we just should add the bracket, go to ln. So ln should be goes like this. ln equals, the first rectangle is f x0 times third x, right? Okay, so like this. F x0, the height times the width plus the second rectangle. So f x1 times third x. The third I ignore, and the continue goes to the last, which is f xn, right? Sorry, f xn minus 1 times theta x, and then the same, right? So we can factor the theta x out. So we can factor out theta x, and then we will have the formula. This time it do this way: f x0 plus f at x1 plus ignore the middle, and then the last f xn n minus 1, okay, times theta x. Can we see? Okay, if I highlight, this is the second formula we formulate. Okay, and the name we call the left, right? So left endpoint. See, the first is the left. The last one is also the left. So each one is the left endpoint approximation. Okay. And of course, this approximation we can see ALN is less than the area, right? So ALN is underestimated. This time is underestimated. Not always underestimated. Depends on what the graph. The graph sometimes it goes up, sometimes it goes down, or sometimes it's not like this. Okay, it depends on the graph. One more. So we call the midpoint estimation. Midpoint estimation or approximation. So we see what is the difference. No bigger difference. So we can see. Okay. So they are the same. A is there, B is here, the function is there, how to estimate the area. So we divided n, divided by n pieces of A to B. So we have x1, x2, x3. Each one you know how to find. And this time for the first rectangle, how to use the height is not use the left endpoint, not use the right endpoint. So it's not this, not that. So we use the midpoint. So we see, well, what is the midpoint? Midpoint is the average of x0 at the x1. Means x0 plus x1 divided by 2 is the midpoint. So this midpoint we find first. Then we can find how high. Okay, or I use this. And see, we can find how high, right? So we use this height. This time is like this. We draw. Okay, so everyone can see, right? So this is the height. So we use this as the height of the rectangle. This approximation is different, and the height this time is f, not at the x0, not at the x1, but at the x1 bar. Okay. So at the x1 bar, the middle point. So this time the height should be the height of each rectangle. Use the midpoint, right? We use the midpoint. We move to the second rectangle. We know x1, we know x2. Find the average is x2 bar. Find the height. See, this is the height. The same. We use this height. I think you are feeling, you have a kind of feeling. So this estimate is very good, right? So this is over, this is under. Look at it, they just cancel. Look, it's very, very close to the area under the curve. Okay, so you put this is f x2 bar. Okay, the same. The third, we're going to find the third is at here. Okay, and then I will put the height rectangle is just like this. Okay, so this time the height is f at x3 bar. Okay, so the I, so you also can do by yourself like this. So how high? The height is not the left, not the right, but the middle. See, so the rectangle is at here. So the height is this. The height is f at xi bar. The last rectangle is going to at there. So this is the very tall. So find the height. Okay, see, and then we highlight. This is the last rectangle. So the height. This time the last one is x at n bar. X n bar. Okay, so we find each height, each width, which is the third x. Third x. So we can find out what is the area, right? So how to find the mn? This the mn is this. Mn equals. So the first rectangle is f x1 bar. Delta x, the width, plus the second fx2 bar, delta x, plus, not the middle, The last is f(x) n bar delta x. Then all the delta x you can factorize. So factor this all the delta x out. What do we have? So we have this f(x1 bar plus f(x2 bar plus f(x)n bar. Okay, so all this is the sum of all the height, and then times delta x is the width. This is the formula for middle point. So I highlighted this, and this one we call the middle point estimation or approximation. Okay, so everyone look at it. So this is the major three type of approximation we need. So either the right endpoint, the left endpoint, or the middle point estimation. So this is the way. The graph is very important. Okay. So now one more. So we look at these three. So can we compare these three estimation? So look at it one more time. This graph is the right endpoint. See, the sum of the rectangle is overestimated, right? This is overestimated, but not always. Depends on what is your graph. And this is underestimated. So which one is better among these right endpoint approximation, the left and the middle? Well, look at it. The middle one looks much better, right? Looks much better than the first two. Usually like this, but not exactly true. Okay. And if we increase the number n, the area will get smaller. If n goes to infinity, all the definition have the same value, which is the area under the curve. That's amazing results, right? Amazing results. And now I'll give you example. Have 3 examples to show. So here is the first example. Can we see the first example? Yes, I think you can see the clear, right? So let's read the questions. Estimate the area under the curve, under the graph of f, which is sin x. Okay, so this is the function. This is the function we need. And from 0 to pi, from 0 to pi over 2. And for some, everyone know trigonometry learned. This is increase to the top, the maximum value. The height, of course, this is 1, right? So everyone knows this is 1. So this is the graph. And the question is using 4 approximate 4 rectangle. So I already divided 1 x. If we see this is x0, the x1, x2, x3, x4, right? So we have 1 part, 2 part, 3 part, 4 parts. So you can find the 4 rectangles. And here, so 4 is information important. And here is right endpoints. Keep in mind, how do you find the rectangle? Keep in mind the height. You have to use the right endpoint as the value. Later is your estimate is underestimated or overestimated, depends on your graph. Okay, and they ask you to sketch the graph. Alright, sketch the graph around your answer to 4 decimal places. Now we need to find what? We need to find the right endpoint approximation, which is right is R4, right? We draw graph first, and we need to draw the graph. What is the point here? What the point here? What the point here? So the delta x is very important, right? This we call the delta x. Delta x. Delta x. Delta x is very important. How to find the delta x? I put it here first. I put it here. What is delta x? Delta x is b minus a, right? Which is if I read the formula, which is b minus a over n. So this time b is pi over 2. A is 0. n is divided by 4, right? Divided by 4. If you do calculation, this is exactly pi over 8. Okay, so this is the one we need. This is the one we need. Okay, delta x is at here. So means what? This is if I say this is x0, we say this is x0. X0 is 0, right? X0 is 0. So what is x1? So I calculate x1. X1 do this. X1 is x0 plus 1 delta x. And if you do the calculation, is how many? X0 is 0. Delta x is pi over 8. So that's pi over 8. See? I put the number. This is pi over 8. The same one. This is x2. X2 we do calculation. Is x0 plus 2 times delta x. And the do calculation is 2 pi over 8. Okay, so I put here 2 pi over 8. We don't need to simplify. Okay, and this pattern looks better. What is x3? X3 is this. From the beginning, plus 3 delta x, and of course is 3 pi over 8. So this is 3 pi over 8. What is x4? You know, x4 is x0 plus 4 delta x. If you're going to is exactly 4 pi over 8 is exactly equals pi over 2. But this is looks better, so I'll use this. Okay, I cancel this. I'll use 4 pi over 8. They are the same. And why use this? Because the pattern looks better. Pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Okay, and then I draw the rectangle. So it says right endpoint. So the first is this high, right? Okay, I draw. See, this is the first rectangle, and the height is f at x1, right? X1 this time. The second is this, the right endpoint. Okay, highlight. This is the height is f at x2. At x2. The third small rectangle is this, f at x3, the right endpoint. The last one, let me see, is at here. So that's f at x4. We know the height, we know the width, the x, then we know the area, right? And then now it's easy. We directly going to do calculation. So now R4, right, equal this. Remember the formula? I will use the formula. Is f at the first x1 plus f x2 plus f x3 plus f x4. The sum of all the heights times delta x times delta x. And then plug everything we need. F is sine. So sine at the first pi over 8. This is sine at pi over 8 plus sine at 2 pi over 8. 2 pi over 8 plus sine at 3 pi over 8. The last sine at 4 pi over 8. Okay, good. Times delta x. What is delta x? Pi over 8. So times pi over 8. See, we have everything. Okay, so let me see what is the answer we get. If you use your calculator do calculation, you should get this. Approximated to 4 decimal, right? 1.1A35. Okay, so this is the one you get. How to get this? If this time the function is easy, so sine, so you can directly type a sine at this plus sine at this. However, you can imagine in this way. If the function is complicated, and also we have a lot of numbers, which means n is very big. And this time I will show you a method that's much easier than this one, direct calculation. I mean, I show you here. Remember, we have a table, right? We have a table. We have a table in the calculator. We can use table in the calculator due to calculation, and especially this is a very useful, especially when n is bigger, is very big, okay, and or the function f(x) is complicated. So look at this. This is very important. I was going to show you how to use the table, okay, in calculator to get this number. Even the function is easy, okay. So let me show you. Yes. So here. Can you see? Here is the calculation. How to use a calculator. So I have a Texas Instrument 83. So we do this calculation. You see? Wait. Okay. So let me see. Yes. Okay, so probably in this way you can see it clearly, right? Okay, so the first we need to do this. So the first what I need to do is not clear, so you'd have to wait a little bit to so the first so I open my calculator. So we need to define what is the function f, right? So go to y, okay, so click here, so go this way. So first we defined the function, so I clear my function. Okay, so y equals is the function, so my function is sine, right? So so I find a sine at x, because x is at here, get the alpha beta x parenthesis. This is my function, but my function, so the x we need to use a radian, this angle. I need to go back to look at my mode. My mode is not that's degree, right? So go to the left, it's radian, okay, good. Now I get a radian, good. And then we'll go to statistics. Okay, this is the table. Click table, click end. So that means not very clear. Okay, so we go into the table. We have 6 columns. I think you are familiar about the table already. The first L1, I don't need this. I'm going to delete. Okay, go down. And then I will put the x here, the first column. And then use the function to the first column. I'll put the value of the function in the second column. Okay, remember what is x? So pi over a, 2 pi over a, 3 pi over all this. I put it there. So pi is this, pi, right, over a is the first. Okay, and 2 pi over a, okay, is the second. 3 times pi over a is the third. 4 times pi over a is the last. So we have x1, x2, x3, x4. We go down to the right. I will apply the function to L1. So find the function is variable, right? So go to variable, y variable. So the first one is function. So int. Remember we defined the function in y1, int. Okay, this is y1, the function, parenthesis, add L1. L1 is at here, second one is L1, parenthesis, and oh, so I think Let me see. Okay, so I put here is wrong. We need to go to the top. So that's the reason. I need to go to the top. So and this I have to see. I put the cross here. Now it should go to the top of L2. The whole column. Go to the top. And this time it's the same. I repeat again. How to find the functions variable? Variable y1. Yeah, did the function. Parentheses L1. The variable. Parentheses. And then this time and see all the variable is there already. This is f. This is exactly f x1, f x2. We all find it. But we need to find the sum, right? So how to find the sum? We have a functions. So here we call the statistic, the basic statistic. And how to find the sum of L2 column is going to statistic calculus, the calculation. One variable statistics, the first, okay, and add L2. L2 is at the second 2. Okay, one variable statistics at L2 column, and look at it, and you have all the descriptive statistics. I think someone you learned sigma x summation. So that the sum. What is the sum? So in the calculus 3.01 something. Okay, so now we find all this right times. We're going to do. We already have the sum times power a is the answer. Okay, let's look at it. The sum is 3.013669746. Okay, 4 decimal. At least you need to leave like 5 or leave it as long as possible. Okay, did the sum and then times pi over a. Times pi is there. Second, this one divided by a. Okay, so that's the answer. How many? 1.1835. 1.1835. 1.18346 rounded to 4 decimal is exactly the solution. Okay, I hope you get it. What I just showed you the table. This is important. Okay, you can imagine if n is much bigger, like 10 or 100. Okay, so you use the table is always do the same. Okay, always do the same. If the function is complicated, it's not a sign. You just define the functions in y1, right? And then apply the functions to x column L1. Easily define all the values, and then use one variable statistic. You can find the sum. The sum times this is the answer. I hope you use that in the future. Okay, so have we answered all the questions? Sketch around my answer. Okay, so we have one question did not answer. Is your estimate underestimated or overestimated? That's easy to look at it, right? See, the rectangle is the area of the rectangle is bigger than the area. It's bigger, overestimate. So we can make a conclusion. Because what? Because R4 is greater than the area on the curve. So what? Overestimate. For our estimation is over. Not always. Okay, so in my case, in our case is overestimate. This is the first example. So we need to go to the second example. So we will change the right endpoint to left endpoint. Let me see. All the difference, everyone. All the difference here is all the difference. All the difference is left endpoint. Okay, so all the others are the same. And I already put the figure. So 0, x1, x2, x3, x4. We just find, right? Okay, so how to find the rectangle? Use the left. Okay, so the left f at 0 is 0, right? Because sin at 0 is 0, so this is nothing. the first height is 0. You can see, right? The first height is 0. Okay, what we can say is this: the first height is f at x 0. The second left endpoint is this. Okay, right? This is the height of the second. The first rectangle is nothing. No rectangle exists. The second is this. The height is f at x1. The third is this. See, easy to find is underestimate. Okay, is the height is f x2. The last one, okay, is this height. You can see the height is f at x3. Okay, the height times the width and added together is what is the approximation? The approximation, the left endpoint. So now we can say the question asks us to find L4, right? The left. L4 is the first nothing. First at the second, the third at the fourth. Which means, remember the formula is f at x0 plus f at x1 plus f at x2 plus f at x3 times delta x, right? Okay, did the formula. Plug into the formula for everything. So the first is sine at 0. Okay, x0 is 0 plus sine at x1 pi over a plus x at x2 2 pi over a plus sine at 4 pi over a. Okay, and delta x is pi over a. And they use the calculator. And if you like it, you use the table, or you do the calculation one by one. The results already find is 0.7908. And this time is underestimated, right? This time is underestimated clearly. Okay, is because what? Because L4 definitely is less than the area on the curve, right? And the function on the curve, so is underestimated. This is underestimate. This is the second. So if you know how to draw the graph, it's very easy. Okay, it's very easy. The formula is here. One more. Thank you for your patience. So one more, almost. Okay, so this time we practice what is the middle point. What is the middle point? So the function is the same, AB is the same. What is different is here. This is the difference. Middle point, I already put the graph here. So x0 0, x1 x2 x3 x4, all we know, but we don't know what is the middle point, right? So you need to find the middle point, x1 pi, x2 pi, x3 pi, x4 pi first. This is easy to find. 0 and the a pi over a, which is the pi over 16, right? Did the first. We find this point. The second, this number and this x1, x2, the average. Add this together, divided by 2 is 3 pi over 8 divided by 2 is 3 pi over 16. See, did the second. The same, this is 2, 3 is 5, so it's 5 pi over 16. The last one is 7 pi over 16. Okay. Easy to find at the middle point, and then we can draw the graph. What is the rectangle? Okay, this is the height. Oh, I just put it here. This is the height of the second rectangle. This is the height of the last rectangle. Is the height. Okay, and then we draw is just like this. Okay, and the first height is f at x1 bar, right? Okay, the second is this height. The height, we draw rectangle. This is f at x2 pi, the height. X3 pi is at here. This is f x at 3 pi. Okay, so this is the top. Okay, like this. F x 4 pi. Okay, so I highlighted it, the third rectangle, did the last rectangle. Okay, so 1, 2, 3, 4. How to find the this time is M4, right? So we need to do this. M4 is, remember the formula, I use the formula, x1 bar plus fx2 bar plus fx3 bar plus fx4 bar delta x. Okay, and plug everything. The first is pi over 16, right? The second is the function add 3 pi over 16 plus sine 5 pi over 16, 7 pi over 16 times delta x is pi over 8. They are the same. Okay, so wait, too little. Okay, so plug everything. You can use the table or do calculation directly. What the answer is 1.0065. Okay, so you can do by yourself. So we have one more question to answer. Is your estimated this time is underestimated or overestimated? Then we're going to see, can you tell? Can we tell? This time we cannot tell. So this is, we don't know, is this area and this area. See, this is over, this is under. Which one is bigger? Do you know? No, I don't know. So look at this graph. This is over, this small part is under. Which one is bigger? We don't know. This part, this small part, we don't know. We don't know. I mean, this is at least is very hard. Okay, so this time is very hard. I say it's hard to tell. Is whether underestimate or overestimate, right? At least from my graph, I cannot tell. Okay, so this is the answer for these questions. From here, one more. We just did the three, the same functions. Can we tell which one is the best estimate? Okay, this is x1 is overestimated. The second left endpoint is underestimated, very clearly, big area. The third one, middle point, is hard to tell, is over or under. Which one is better? Which one is the best? At least in this example shows the middle point is the best, okay, for this example. And usually for a lot of functions, the middle point is the best among left right, but it is not exactly. Yeah, hope you enjoy. And this the one. Thank you.